to the vector n. Okay. Well, what else? It is that if a point P, so a point P, x, y, z lies on this plane, if it satisfies the equation on the plane, if the equation. So this type of equations always define planes, and planes always have such equations. For example, let's consider some equations. X plus y plus z equals 6. Well, this is an equation of a plane. This is the plane. This is the equation of the plane, which passes through. Let's give one point, for example. Well, let's write one point on this plane. For example, 1, 2, 3. This point satisfies the equation, so it is a point on the plane, and it is perpendicular to the normal vector, as we say. So what is the normal vector? We read 1, 1, 1. Plane through this one and perpendicular to this normal vector. Okay, let's write one more. X plus y equals 0. This also defines a plane. Again, let's write. So this is, let's find a point on this plane. Any point that satisfies the equation. For example, x is 1, y is minus 1. Z could be anything. For example, 0 or anything. Yeah. Let's say 0. Okay. Perpendicular to what vector? Normal vector. Well, remember, we will read this normal vector from the equation. So this normal vector will be the vector whose components are the numbers in front of the variables x, y, and z. 1, there is 1, there is 1, and z does not appear. This means there is 0 in front. So 1, 1, 0. X plus y equals 0. All right, let's take one more. Okay. X equals 0. This is also a plane because, for example, x is 0. Now y and z could be anything. So let's take, for example, 1, 1, 1, 2. For example. And it is going to be perpendicular to what vector? Of course. The number in front of x is 1. The others do not appear, so this means the numbers are 0. Okay. Similarly, we can write other equations. But let me draw your attention to this one. So x is equal to 0 is, you know, the YZ plane in the plane. So where is this line, this plane? So this is x, y, z. So this is the set of points whose x coordinates are 0. This would be the yz plane. So this is the yz plane. X equals 0. Similarly, xz plane. What would be the equation of this one? In the xz plane, you see the y coordinate will be 0. So the equation of xz plane is y equals 0. And similarly, yz plane, xz plane, and then xy plane. The equation of xy plane is z equals 0. Let's write the normal vectors. So what is the normal vector here? Z is equal to 0. We are talking about xy plane here. So let's write one vector which is perpendicular to the xy plane. For example, this k. K is normal vector here to the xy plane. Similarly, for this yz plane, let's write a normal vector. Normal vector for the xz plane. We can take the unit vector in the direction of y-axis. So it will be j, for example. Remember, this is the vector 0, 0, 1. This is the vector 0, 1, 0. And similarly, for the yz plane, we have this normal vector, but you know this is same as I. All right. Okay. X plus y equals 0. So these are called coordinate planes. They are also called coordinate hyperplanes, but for space, plane and hyperplane are the same. And the thing to keep in mind is that they have equations of this type. So any equation in the plane will have, any plane in the space will have an equation like that. These are examples, and we have many examples, as we will see. All right. Well, does a plane have only one equation? Of course not. It depends on the normal vector first, and also it depends on the points that we use to write it. All right. So remark. Two planes coincide, are the same. Coincide. If and only if. Only if their equations are multiples of each other. Their equations are multiples of each other. For example, x plus y plus z equals 6 and minus 2x minus 2y minus 2z equals minus 12. These two planes coincide. These planes coincide. Because they are multiples of each other, right? If you multiply this one by minus 2, you get this one. All right. So this is how we understand if two planes are the same. Okay, now let's move to understanding when two planes are parallel. So this remark shows that how to find coincident planes is something very easy. More generally, let me write, more generally, two planes are parallel if and only if their normal vectors are parallel. Their normal vectors, if and only if their normal vectors are parallel. For example, again, let's write examples. Let's consider x plus y plus z equals 6. This is one plane. Another plane, let me write, 7. Well, these planes will be parallel because, you see, are parallel. Why? Because their normal vectors are parallel, right? In fact, the same. So the normal vector here is 1, 1, 1. The normal vector here is also 1, 1, 1. Okay, let me write one more. 3x plus 3y plus 3z equals 5. All three vectors, all three are parallel. Why? Because their normal vectors are parallel. So normal vector of the first one is, you see, 1, 1, 1. The normal vector of the second one is also same, 1, 1, 1. Normal vector of the third one, 3, 3, 3, right? They are all parallel because this one is multiple of the others. So two vectors, are parallel if and only if they are multiples of each other. So how do these planes look like? So they are parallel planes. So they will look like the following. So if we draw a picture. Yes. So parallel planes, and this normal vector here is n, for example, 1, 1, 1. Yeah. This 1, 1, 1 is also a normal vector for the third one. Right? It could be shorter, but fine, because normal vector is just a vector which is parallel to, which is perpendicular to this, to the plane. All right. Okay, so you see that these vectors are parallel, but they do not coincide. So, for example, this plane and this plane are different, right? Because in the first one, x plus y plus z becomes equal to 6. In the next one, it becomes equal to 7. So they are different. And if we think in terms of this remark, you see that we cannot get these two equations from each other by multiplying. So whatever I multiply this equation, both sides, I will not get this one. All right. Okay, so this is how we understand if two vectors are parallel. We just look at the normal vectors. If they are parallel, this means planes are parallel. And understanding if two vectors are parallel is very easy. We just look if they are multiples of each other. Okay, now what happens if two planes are not parallel? Then they will intersect, you know, right? If two planes are not parallel, then they will intersect. Like that. So this will be one plane, for example. This will be another plane. They will intersect. And last time we had an example to see how we find the intersection line. So when two planes intersect and they are not coincident, then they will intersect along a line. And remember, we know how to write the equation of this line, as we saw on an example. Today we will discuss another thing. So you see that when they intersect, there will happen an angle alpha. So how to find this angle alpha? Let's discuss this now. So angle between planes. Between two planes. Okay, so you see, this will also be very easy. So this angle alpha will be the following. So let alpha be the acute angle between planes P1 and P2. Planes P1 and P2. So this is P2, P1. This is P2. All right. Then this angle alpha, alpha is acute angle, so it will be between 0 and pi over 2. So let me write here, alpha between 0 and pi over 2. Okay, then this, how can we compute this angle alpha? Well, you remember that we can compute this. This could be very difficult if we just look from this outside, but when we hear the term angle, we remember that we can compute angle between vectors very easily using dot product. So let's now relate this one to angle between vectors. Now, what vectors we have for the planes? We have this normal vector, right? So we have one normal vector here, n1, and another normal vector here, n2. All right. Well, the thing is that this alpha will be, alpha becomes equal to the acute angle between the normal vectors. The normal vectors. Between their normal vectors. Let's say n1 and n2. Yes, but I'm saying acute angle. Yeah, in this picture, for example, n1 and n2 are like that. So there is n1 is like that, n2 is like that. So, and this angle between them will be also same as alpha. So normally, n2 could have been in the other direction as well, but then this angle will not be acute angle. It will be pi minus alpha. So we will take this alpha again. Okay, so cosine alpha will be absolute value of the angle between N1 and N2. So remember, just let me write here, N1. So you see, normally this is the formula to give the cosine of the angle between two vectors N1 and N2. However, again, as I said, it could have been that. So we could have used this one as N2. So this would be this yeah, so I should be careful. So then alpha is equal to the acute angle between their normal vectors. So I should be more careful then, as I said. So this angle will be here, cosine alpha times, it will be absolute value of this one. So let me write it more carefully. Then alpha is equal to so let's denote this one by theta. Yeah, I should have done it this way before. So then alpha is equal to theta or minus theta, where theta is the angle between normal vectors N1 and N2. N1 and N2. Yeah. So the picture will be either will be like that. So this will be the case theta. This is the theta. Then the angle alpha will be here theta, or it will be pi minus theta. Then cosine alpha will be this one. This will be equal to cosine theta. All right. So this is how we find the angle between two planes. Let's now see it on an example. So find the angle. Find the angle. Angle. Angle between the planes x plus y equals 0, x plus z equals 0. Okay. So all right, let's write the normal vectors. Normal vector of the first one is 1, 1, 0. Normal vector of the second one equals 0, 1, 0. All right, then this angle between them, cosine of it, will be absolute value of...
Hocam ikincisi sanırım 1, 0, 1 olacak.
Yeah, 0, 1, 1. 1, 0, 1, pardon. N1 dot N2 divided by length N1 times length N2. All right, let's find the product. So 1 times 1 plus 1 times 0 plus 0 times 1 divided by length of 1 is going to be equal to, you know, 1 squared plus 1 squared times 1 squared plus 1 squared here. All right, so it will be equal to 1 over 2, you see. Okay, then what is angle alpha? Cosine alpha, it will be 60 degrees, right? So pi over 3. Okay. Again, this is for acute angle. Let's draw these planes. X, Y, Z. All right. So the first equation, how do I sketch it? X plus Y equals 0. So you see, this X plus Y equals 0. It would be useful to look at the first how they intersect with this, with the XY plane. So let's see how it intersects with the XY plane. So this plane, X plus Y equals 0. How does it intersect with the XY plane? Well, XY plane, equation of XY plane is Z equals 0. And so it will intersect with this XY plane along the line X plus Y equals 0. So this is Y equals minus X. So you see, Y equals minus X will be like that. So, yeah. And so X plus Y equals 0. So for example, X is 1, Y is minus 1 will be in here. So, or X is minus 1, Y is 1. Yeah, for example, minus 1, 1, 0 will be on it. And then this plane will be like that. So diagonal, it becomes at the diagonal. So, yeah, like that. This is X plus Y equals 0. So it is above this one, and you see it will be parallel to this z-axis. So this plane will be parallel to z-axis. I will talk more about this. Similarly, you can draw X plus Z equals 0. So it will be, if you think, diagonal cutting that way. Unfortunately, it is not easy to sketch this one. So X plus Z will be, yeah, it will be like that. Okay, as I said, I will talk more about this. Let me take a few more examples before going into pictures. All right. Okay. More examples. So example. Find the angle between the planes X minus Y plus 3Z equals 0 and three Y plus Z equals 0. Okay, solution. We need to compute the angle between the normal vectors. So let's write the normal vectors. N1, 1, 1, 3. N2 equals 0, 1, 1. All right. Let's now compute this formula. For this, we need to compute dot product. Anyway, so let's compute the dot product.
The second normal vector should be actually 0, 3, 1, shouldn't it?
0, 3, 1, yes. One plus times 0 plus. Oh, I should take this x minus y. Yeah. Okay, 1 times 0 plus minus 1 times 3 plus 3 times 1 equals 0. So you see, these vectors are perpendicular to each other, meaning that the angle between them is 90 degrees. So the angle between these planes are also 90 degrees, meaning they are perpendicular to each other. So these planes are perpendicular to each other. So they are like the following. So one of them is here. The other one is like that. And the angle between them is 90 degrees, which we can easily detect just looking at the dot product of the normal vectors. Let me take one more. Let's find the angle between the planes. Planes. Z equals 0, 0, and y equals 0. Well, do we recognize these planes? Yes, right? Z equals 0 is the plane, xy plane. Y equals 0 is xz plane. And xz plane. And we know that already these these planes are perpendicular. So x, y, z. So xy plane is, you know, this plane, this x, y, this plane. And what is xz plane? Xz plane is also here. This one. 90 degrees, but now let's see it. So normal vectors, let's write. N1, normal vector of the first one, this equation. Well, so 0, 0, 1. This is what we call K, right? This is the normal vector of this xy plane. What about this one? Normal vector of the next one will be y is 0. So there is 1 in front of y and 0 in front of x and in front of z. This is j. Okay. Let's now compute dot product. N1 dot N2. This will be, you see, 0, right? If you multiply. So they are perpendicular. XY plane and XZ plane. This angle is 90 degrees. Okay. All right. Now, so we now know the relation between two planes. So two planes could be coincident. I mean, they may give, they could be the same planes. We know how to see this. Next, they could be parallel, non-intersecting. We also know how to see this. And then now we also know what happens if they intersect. Let's now consider the relation between planes and lines. So what can happen between a plane and a line? So two things could happen, right? If we think. So it can happen that this is the plane and there is the line. They may intersect. This is plane, line. They may intersect, fine. Another thing that could happen is that they may not intersect, right? So they may not intersect. How? They could be parallel. So plane could be parallel to the line. L, and the plane is intersecting. Parallel. So this is how position of a plane and intersect the line.
Hocam sesiniz gidiyor. Mikrofonunuz çok cızırtı yapıyor. Ses gitti, daha demin duyamadık.
Ses geliyor mu şu anda? Geliyor mu?
Geliyor hocam.
Okay. So I want to say positions of a plane with respect to a line. So there is one more. Okay, these two possible, but there is one more possibility. Is that the line could be inside the plane. It could be lying in the plane. So contained. So intersecting at the whole line. Along the whole line. So let's see now examples for how we compute these in each of these possibilities. So I'm going to take a line and a plane and see how I can compute this intersection. Apparently, I need to take it from here. Okay. So let P be the following plane, x minus y plus 2z plus 1 equals 0. And line L, the line given as follows, parametrically, t plus 1, t minus 2, 3t plus 1. Okay. So find the intersection. Find L intersection P. Okay, so in the intersection point, so which one will happen, we will see. So to find the intersection, we should look for points which are in both. So we are looking for points which are on this line and also on this plane. So the intersection point will be on the line. So it will be a point like that. Coordinates will be t plus 1, t minus 2, 3t plus 1. And it must also be in the plane. So it must satisfy the equation. So let's put this one into this equation. So for the intersection point, we will have, so I'm going to put t plus 1 in as x, intersection, and then minus, so this will be for y, so t plus t minus 2, and then this will be z, so plus 2 times z is 3t plus 1, plus 1 equals 0. Okay, from here I'm going to find t. So I'm going to have t minus t equals 0. So I will have 1 plus 2 equals 3, and also 3 plus 6t plus 2 plus 1 equals 0. Yes, from here I will get that 6t equals minus 6. So t equals minus 1. Okay, so I got that this intersection will occur when t is equal to -1. Okay, so what is the point then, the intersection point? Then the intersection point, will be, so I'm going to put t equals -1 in here. So -1 plus 1, -1, -2, 3 times -1 plus 1. Okay, so it will be 0, -3, and then -3 plus 1, -2. So it is 0, -3, -2. So you see that I got only one intersection point. So the picture for this line and plane is like that. 0, -3, and -2. Okay, so L intersection P is this one. So L intersection P is this one. Okay, this intersection. So as part B, let me ask you the following. So what is the, so is, now that it is going to be a picture like that, it is intersecting at one point. So I may ask you the angle between this L and P. So before that, let me ask you the following. So is L perpendicular to P? Perpendicular to P? And also, yeah, I guess I want to ask the angle between this line and P, but it is not easy to ask this one. So that we should also discuss what is the angle between a line and a plane, which is not trivial actually. So for the moment, I can ask you if how determine if L is perpendicular to P. So is it the case that this line intersects this plane at the right angle? So we can talk about this one next time. Okay. So this would be an exercise for you. We can stop here for today. All right. So that's all for today. If you have questions, I can answer.
Hocam, can I ask something?
Yes.
How do you find the rate of change of a plane?
Rate of change of a plane?
Yeah, the derivative, basically.
There is no such thing as derivative of a plane.
Okay.
I don't know. The derivative of a function we have. Derivative of a plane, we do not have derivative of a plane.
No, the rate of change. Can we determine something like that?
Oh, the rate of change, you can talk about the rate of change of a function, but here we do not have a function.
Okay, thank you.
Plane is not a function. Okay, so we can stop here, I guess. We can continue next time. Thank you very much for your attention.